In this video, we will discuss the difference between scalar quantity and vector quantity, as I described it in my previous lectures. But now we will formally see the difference between scalar quantity and vector quantity. So, in scalar quantity, scalar quantity is a physical quantity which has only magnitude and no direction. On the other hand, a physical quantity that has both magnitude and direction is called vector quantity. So that means if I say a 5 meter, if I say 5 meter, a stick is a 5 meter of length, then I can only represent the length with the value of the magnitude or with the value or magnitude. So this is known as value or magnitude. But in vector quantities, suppose I said the velocity of a car is 20 meter per second. So this is the magnitude of this car. But if I say it moves along the right direction, then this whole information is known as vector quantity. On the other hand, in scalar quantity, we only represent the speed of the car is 20 meter per second. So this is known as speed, which is a scalar quantity, and this is known as velocity, which is a vector quantity. Okay. Then second one is addition, subtraction, or multiplication of scalar quantities are done by the simple arithmetic rule. Means if I said I add 2 stick of 5 meter, then the total length of the stick will be 10 meter. Total length in the stick will be 10 meters. So I did some arithmetic operations there. I don't have to apply anything rather than simple arithmetic rule. On the other hand, addition, subtraction, or multiplication of two vectors cannot be done by simple arithmetic rules. For this, we have some laws like additions of vector, subtraction of vector, or law of parallelogram. These laws, or we can say the multiplications of vector like scalar product or dot product, we have to apply these rules or these arithmetic rules there. There cannot be done by simple arithmetic rules. These are the arithmetic rules but not simple arithmetic rules. Here I can use the simple arithmetic rules. Then a scalar quantity is changed due to the change of its magnitude. Like if I change only the magnitude, if I said the length of the stick is not 5 meter, instead it is now become 10 meter. So I change the value or I change the magnitude of this stick. So the whole value is changed. But in vector quantity, it is changed due to the change of its magnitude, direction, or both. So if it can be change of its magnitude, like I said, a car moving at 30 meter per second. So it changed the value of vector. But if I say that the car is moving 20 meter per second, but in the left direction. So in that case, as the direction is changed, so whole vector quantity is changed. Or we can say that we can change both of the information so that the whole quantity, then the whole vector quantity will be changed. Then a scalar product of two scalar quantities can be never be zero unless one of them is 0. So this is the extra line. This is extra line. So we can say the scalar product of two scalar quantities can never be 0 unless one of them is 0. So here it says that if I multiply two scalar quantity, like I said 10 meter into 0 meter, then the resultant quantity will be 0. But in vector product, two vectors quantities can be 0 even none of them is 0. So here we applied like if the two vectors are in parallel, then their cross product will be 0. If I said that the both vector is perpendicular, perpendicular means 90 degree at right angle, then their dot product will be 0. So it can be 0 according to the how the angle between the two vector quantities are applied. So it can be 0. In that case, the two vector quantities must not be zero, but because their angle is zero, their angle is parallel or perpendicular. So in that case, a vector product of two vector quantities can be zero, even none of them is zero. And the last one is scalar product of two scalar quantities always gives a scalar quantity. So it says that when I said that I multiply the 5 meter length of stick with 2, then the total length of the stick will be 10 meter. So I actually applied some simple arithmetic rules, and this 10 meter is now a scalar quantity, not a vector quantity. So that this is a scalar quantity. Suppose 2 meter. This is a scalar quantity, and this is a scalar quantity, and the new quantity is also be a scalar quantity. Here, in the vector case, a vector product of two vector quantities can be vector quantity or scalar quantity. In vector quantity, it is known as vector cross product. It is known as cross product. Cross product. And if it is a scalar quantity, the product of two vectors is a scalar quantity, then it is known as dot product. What is dot product? Dot product. So this is the main difference between the vector quantity and scalar quantity.